Hello, welcome everyone. Today we are doing Intermediate Mathematical Challenge. It's a Wednesday, 1 February 2023. It's a 2023 paper. You can clearly see the time allowed is 60 minutes. So there are 25 questions that you have to complete in 60 minutes, that is in 1 hour. As you can see in this paper, the question 1 is very simple, right? But as you move downwards, you will find more harder and harder questions. So let me start with the first one. It says which of these numbers is a neither multiple of 3 nor a multiple of 4. It's very easy. We know how can we calculate the multiple of 3? Their addition should be a multiple of 3. That means 6 plus 1, it gives me 7. 7 is not divisible by 3. So definitely it's not a multiple of 3, but it's a multiple of 4, because to know whether a particular number is divisible by 4 or not, you have to see the last two digits. And the last two digits should be a multiple of 4. 4 times 4 is 16. So yeah, definitely this is a multiple of 4. So that's not the answer. 21. 2 plus 1 is 3 and 3 is divisible by 3. That means 21 is a multiple of 3. So this is not our answer. 28. Definitely it's a multiple of 4 because 7 times 4 is 28. 34. 34 is not divisible by 4. And 4 plus 3, that is 7. It's not divisible by 3. That means clearly this is our answer. Moving on to the next one. What is the area of rectangle? Triangle. This one is a triangle and you can clearly see it's a right angled triangle, where this is your height, this is your base, and 5 is your hypotenuse. So don't do half times 4 into 5, which will easily give you 10 centimeter squared, and no, you have to see what exactly which side they have given, and clearly this 5 centimeter is a hypotenuse. So when you use Pythagoras theorem to calculate the third side, it turns out to be 5 squared is equals to 4 squared plus x squared. Let me write this bx. So bring it here. 25 minus 16 equals x squared. X squared is 9 and x will be plus minus 3. Negative cannot be a length. So answer is 3 centimeters. Now we have half times base times height. Base is 3 we have calculated. So half into 3, and height we have calculated as 4. So answer is 6 centimeters squared. Therefore our answer is A. Moving on to the question number 3. What is the value of 1 minus 2 minus 3 minus, okay, this is inside the brackets. So we always have to start with the most inside bracket. That means this one is the most inside bracket. This one. So from here, what we can do, I'm just deleting these all. Keep on deleting as we are lacking the space. So 1 minus 2 minus 3 minus 4 minus the most interior bracket is 5 minus 6, which is minus 1. So keep it inside the bracket. Now when you open this one, 3 minus 4, as negative 1 is already outside this bracket, we know whenever we expand it, we need to multiply whatever is outside the bracket. Negative is outside the bracket, so negative times negative 1 will give you plus 1. Minus 2, 1 minus. Now this is our bracket that we have to solve. So 3 minus 4 is minus 1 and minus 1 plus 1 is 0. So 1 minus 2 minus 0. This is inside the bracket as well. So write this like this. Now 2 minus 0 is just 2. So 1 minus 2 is negative 1 and our answer is B. Question 4 says the diagram shows a square of its two diagonals and two line segments, each of which connects two midpoints of the side of the square. What fraction of the area of the square is shaded? See, this is the figure they have given, and it says it's two diagonals and two line segments. Two diagonals, that means these two diagonals they are talking about. This is one diagonal, this is two diagonal, and we know in a square the diagonals divide the square into four equal triangles. So as of now you're able to see four triangles, they all are equal in area. And then there are two line segments as well, these two line segments, each of which connects two midpoints of the sides of the square. These are connecting two midpoints. That means if suppose the length of this be 4 centimeters, then this will be 4 centimeters as well. Two line segments, each of which connects two midpoints of the sides of the square. So this is the midpoint, and you can say this be the midpoint as well. So this length be 4, 4, this length be 4, 4, and this length be 4, 4. If I'm assuming that the total length is 8 centimeters, each side is 8 centimeters, if I'm assuming, then it will convert into 4, 4, 4, 4, 4, 4 because they are equal. So now we know that this diagonal, right, it's dividing and they meet at the midpoint. So clearly in this case you will find from here you can understand that this is a triangle, and if I draw it like this, there are four equal triangles. This length, this is basically an isosceles triangle, and this, because we know that it is meeting at midpoint 4, 4, so each length is 4, right, and these two lengths are equal, that means these two lengths are equal. You can clearly understand that this triangle, they all four triangles are equal, they are congruent, and that means each will be divided into four equal triangles. So I can do like this as well, like this, like this, like this. So there are total 16 triangles. It's very small, I don't know, like it's definitely not a very much clear, but from these two information that is given, we can understand that the each line is dividing into equal parts, right? So base is exactly equal. Each one is isosceles, that means their other two sides are also equal, which makes all these 16 triangles congruent. That means they, if they all are equal, what fraction of area of the shaded is that? So total square is made up of 16 congruent triangles. So definitely the shaded portion is, suppose if I say this is 1 unit, its area is 1 unit. So total square is divided into 16 same 1 unit triangle. Over 16 will be the total area of this square. So 1 over 16 would be the fraction, that is D would be the answer. Question 5. We know that 1 plus 2 plus 3 plus 4 equals 10. It is also true that 1 cube plus 2 cube plus 3 cube plus 4 cube is equals to 10 to the power of n for some integers n. What is this integer n? See, just even you don't need not to know the formulas, just add starting 1 or 2 and you'll get the answer. See, we know 1 plus 2 plus 3 plus 4 is 10. So just add them, simple. 1 cube is 1, 2 cube is 8, 3 cube is 27 and 4 cube is 64. When you add them together, you will get 9, 36. 64 plus 36 is 100. That means 10 to the power of 2 is 100 and would be 2. Simple. Answer is B. Next is, to draw a 3 by 3 square grid, you need 8 straight lines as shown. Here there is a figure. How many straight lines do you need to draw a n by n square grid? See, to draw a 3 by 3 grid, you need 8 straight lines. How? 1, 2, 3, 4, 5, 6, 7, 8. These 8 lines are required to draw a 3 by 3. Now, if suppose I want to take another, suppose 5 by 5 grid. Okay. So, it would be 1, 2, 3, 4. Then 5, 6, 7, 8, 9, 10, 11 and 12. In this way you can clearly see I drew 12 lines to make 5 by 5. Now let me see to make 4 by 4 how many straight lines I have to draw. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I drew 10 lines. 10 lines to make 4 by 3. Now just see the combination or the relation. For 3 by 3, I'm writing it here, 3 by 3, 8 straight lines were required. For 4 by 4, 10 lines are required. For 5 by 5, 12 lines are required. You can clearly see that 2, 2, 2, 2, 2 is adding, right? So from here to draw n by n, how many I have to draw? N by n. What's the relationship between these two? You can see if you split it into horizontal and vertical lines, you can clearly see this is 8. That means 4 plus 4. You are making 4 horizontal line and 4 vertical line. That's the meaning of it. So if I'm going to compare it with the same, that means what? Either this one. This is 5 horizontal line and 5 vertical line. That's why I have drawn it here. You can clearly see it. How many? 1, 2, 3, 4, 5, 6. 6 horizontal line for 5 cross 5. 1, 2, 3, 4, 5, 6. 6 vertical lines for 5 cross 5. So 6 horizontal and 6 vertical lines. Similarly for 4 cross 4 you can see 1, 2, 3, 4, 5 horizontal, 1, 2, 3, 4, 5 vertical. So every time to get 3 cross 3 or 4 cross 4 you are making plus 1 horizontal and plus 1 vertical line. So in that case what you can conclude that to draw n cross n you just need n plus 1 horizontal line and n plus 1 vertical line. So n plus 1 horizontal line, n plus 1 vertical line, which will give you 2n plus 2 or 2 times n plus 1. So these will be the total number of straight lines that you have to draw, which is E. So answer is going to be E. Now moving on to the next one. It says what is the 0.15% of 60 million? So how many zeros are in 60 million? There are 7 zeros. So I can say I need to find 15% of 0.15% of. So it would be 6 into 10 to the power of 7 into 0.015 over 100. This is how we can calculate a percentage. So 6 into 10 to the power of 7, when I convert 0.015, it can be written as 15 into 10 to the power of negative 3. It means the same. Over 10 squared. From here I can cancel it out. It turns out to be 6 into 10 to the power of 5 into 15 into 10 to the power of minus 3. 15 into 6 will give you 90 into 10 to the power of 5 minus 3 is 10 to the power of 2. Answer is 9000. So our final answer is going to be 9000, which is B. So this is our correct answer. Moving on to the next one. Root of root x is equals to 3. So to calculate the value of x, obviously I need to remove that root part above. So root of root x is equals to 3. So first we need to square. So when I square both the sides, it will be root x equals 9. The square will remove this root, it will become 9. Now I need to square it one more time. So squaring will remove this root as well. So x is going to be 9 squared, which is 81, and answer is E. Moving on to the question number 9. Marin wrote down 2023 and one further number. What was the median of her first 5 numbers? See, definitely in this case you will get, you have, we don't know the value of x, so we have to make the possible values. Say for example, because these are 5 numbers, so x can be smaller than 0, it can be -1, -3. So the first case is x is the smaller. Whenever we calculate a median, we always write them in increasing order. The numbers are written in increasing order. So suppose x is the smallest one, then 0, 2, 2, 3. This is the first case. Second case could be, it could be greater than 0. So 0 x, because I'm arranging in ascending order. So x would be here 2, 2, 3. That's the second case. Third case is it should be greater than 2. Obviously it cannot lie between 2. It should be greater than 2 or equals to 2. In both cases, it can either be greater than 2 or equals to 2. In both cases, I can write it like this. Now the next is, it's the furthermost, that is the greatest one, even greater than 3. So it will be 0, 2, 2, 3x. Now let me see one by one what will be the median in each case. For the first one, we know the median is the middle value, which is 2. So in this case, 2 is the median. Middle value, 2 is the median. Middle value, 2 is the median. And middle value, 2 is the median. So in any case, you are going to have the same median, which is 2. So answer is going to be D. Now question number 10. Across, this is a puzzle given here. Then you have to fill the values. It says across a power of 5. That means here you have to write a 4-digit power of 5. A power of 6 downwards. Let me start with this one because it's just a 2-digit number. It's very easy. Any power of 6, 6 to the power of 1 is 6. It's a 1-digit number. 6 squared is 36. 6 cube is 216. So you can clearly see on 6 cube we have moved to 3-digit. 6 to the power is a 1-digit. So only 6 squared will give you a 2-digit number, which is 36. Now a power of 5, we have to see that power of 5 which is a 4-digit and starting from 3. So you will get a number 3125 when you make a power, because 5 squared 25, 5 cube 125 and so on, 1625. So on, if you keep on multiplying, see 5 square 25, I'm just writing 5 squared 25. Then 5 cube would be 125. Then 5 to the power of 4, 625. And so on. You'll get one value which is 4-digit and starting with 3, that is specifically 3125. Then a power of 4. A power of 4, that means we have to find a 4-digit power of 4. That means 4 to the power of 1, 4 to the power of 2. If you keep on doing 4 to the power of 3, 4 to the power of 4, you will find a value which is a 4-digit and ending with 6. And that value is 4096. Now it says each of the digits from 0 to 9 inclusive are used to fill the cells of the cross number. Every number from 0 to 9 is used to fill the cell except for the two numbers. So from 0 to 9, let me count what numbers we have and what we don't have. 0 we have, 1 we have, 2 we have, 3 we have, 4, 5, 6, no 7, no 8, 9. So from 0 to 9 except 7 and 8 we have filled all the numbers. So what are the sum of these missed numbers? 7 plus 8 is 15. Answer is D. So in this way we can solve this. Now let me move on to the next one. Jill was given a large jar of jam. She gave 1/5 of the jam to Jen. Jill then gave 1/13 of the remaining jam to Jess, and Jill was left with 1 kg of jam. What was the weight in kg of the jam in Jill's jar at the start? Suppose Jill was given a large jar of jam with weight of x kg. She gave 1/6 of the jam to Jen. So x over 6th to Jen. That means the remaining now she has will be x minus x over 6, which is 5x over 6. I just subtracted x by 6 from it. Why? Because she has already given it to Jen. Jill then gave 1/13 of the remaining gem. 1/13 remaining is 5x over 6. 1/13th will be this. To Jess, Jill was left with 1 kg gem. Now the remaining is 5x over 6 minus 5x over 6 into 13, and that is equals to 1. So 5x over 6, if I take out, 1 minus 1 over 13 is equals to 1, or 5x over 6 into 12 over 13. 1 minus 1 over 13 is 12 over 13 equals 1. So this will be 10x over 13 is equals to 1, or x is equals to 13 over 10, which is 1.3 kg. So initially Jill had 1.3 kg of gem, which is B. In the diagram PQRS, PST is an equilateral triangle, SRUVW is a regular pentagon. Now what is the size of WTS? WTS, that means WTS, this angle. Now to calculate this angle, if I join this together, I'll get to know, first thing I should understand that PQRS is a square. So say for example the length is x. So definitely x, x and x. PST is an equilateral triangle. In an equilateral triangle all the sides are equal. That means this is also x and this is also x. Obviously. And SRUVW is a regular pentagon. If RS is x, that means the remaining would be x as well. So clearly all the sides are x. The figure that you can see all have the same side x length. Now, if I join this together, clearly I get to know that SW is x and ST is x as well. So it's basically an equilateral triangle. So this angle would be and this angle would be equal. So my main aim is to calculate this angle. If I'll be able to calculate this angle in this triangle, I can calculate the other two angles as well. If you see, we can easily calculate this angle because it's an equilateral triangle. And in equilateral triangle, all angles are equal, which is equals to 60 degrees. So I can say this is 60 degree. Next is square, and we know all the sides are equal and all the angles of a square are 90 degrees. So this is 90. A pentagon. There is a formula to calculate sum of the interior angles of a pentagon or of any quadrilateral polygon is n minus 2 into 180. So n minus 2 into 180, how many sides? N represents the number of sides in a pentagon. How many sides are there? 5 sides. 5 minus 2 into 180. That means 180 into 3 will give you total angles. Now, to calculate one angle divided by, because all angles are equal in a regular pentagon, so divided by number of sides or number of angles, you will get the value of each angle. So that will give you 3, 6. 36 into 3, which is 108. So this is 108. So obviously the remaining would be, we know the angles in a circle, all the angles around it equals to 360. So let I say this be x angle. So x plus 90 plus 60 plus 108 is equals to 180, 360 degrees, because they all add up to 360 degrees. So this will be 150 and 258. X is equals to 360 minus 258, which is 102. If this is 102, now see this triangle. Only I'm talking about this triangle specifically, that is the purple triangle. This purple triangle is like this. I'm drawing it here, which is W, S and T. And we have calculated this angle, which is 102. And these two angles, because I told you WS and ST are equal, so it's an isosceles triangle. And opposite side of equal sides of an opposite angle of an equal sides of a isosceles triangle are always equal. So this would be Y and this would be Y. If I apply angle sum property, that means sum of all the angles of a triangle equals to 180. From here, 2y is equals to 180 minus 102, that is 78. So y is equals to 78 over 2, which will give you 39 degrees. So answer is going to be E, 39 degrees. Moving on to the next one. The mean of P and Q is 13. The mean of Q and R is 16. The mean of R and P is 7. What is the mean of P, Q and R? See. Mean of P and Q is 13. That means P plus Q is 13. Over 2 is 13. On cross multiplying, I'll get P plus Q is 26. Next is Q and R is 16. So Q plus R over 2 is 16. So I'll get Q plus R as 32. Similarly, R plus P is 7. R plus P over 2 because mean. So on cross multiplication, I'll get R plus P is equals to 14. Now I'm left with these three equations. If I add them all up, it will give me 2P. Left hand side would be 2P plus 2Q plus 2R. And right hand side will become 272. Take out 2 out as common. It will be P plus Q plus R is equals to 72. Now divide both the sides by 2. I'll get P plus Q plus R is equals to 36. What is the mean of P plus Q plus R? Sum of all the data divided by number of data. That means P plus Q plus R over 3. We just calculated P plus Q plus R is 36. So replace P plus Q plus R as 36. So 36 over 3 will give you 12, which means 12 is the correct answer. Now the next one. A regular octagon PQRSTUW has sides of length 2 cm. When I shade the rectangles PQTU and RSVW, 4 triangles inside the octagon remain unshaded. What is the total area in centimeters squared of these 4 triangles? See, a regular octagon. Let me just draw a regular octagon. PQRS, so let I name PQRSTUVW. And each of length 2 centimeters. We have to shade rectangle PQTU. PQ and TU. This is a rectangle PQTU. And RSVW. RSVW, this one. So if we shade it, the unshaded would be these triangles that we can see. These are the triangles that are unshaded. Since we know that each side is 2 centimeter, that means this is 2, this is 2, this is 2 and this is 2. Apart from it, this middle section is definitely a square of 2 cross 2. Now, whatever this length is equal because this is rectangle, and this is rectangle, this is rectangle. So this middle part, this has divided into, you can say, 2 equal parts. This part and this part is equal, this part and this part is equal. Similarly, this part and this part equal, this part equal. If you see this figure, you will get to know that basically these all four triangles are congruent triangles. So when I join them together like this, I'm gonna get a square basically of side 2 to 2 centimeters. Why? Because this is 90 degrees. They all are here 90 degrees. So they are meeting at 90 degrees as well, right? Obviously the question is that they can be obviously a rhombus as well, but this is also 90 degree because it's forming a rectangle. So which means definitely this is going to be a square. Square with side 2. So what will be the area of a square with side 2? 2 times 2, which is 4. So answer is going to be C. Here C. How many of the following polygons could exist? A triangle with all three sides the same length but three different interior angles. A quadrilateral with all four sides with the same length but for four different interior angles. A pentagon with all five sides the same length but five different interior angles. See, first we have to cancel. A triangle with all three sides the same length but three different interior angles. The only triangle which is possible having all the three sides are equal or of same length is an equilateral triangle. And we know that all the angles of an equilateral triangle is 60 degrees. So it's not possible that you will find all three different interior angles. This one is incorrect. Next is a quadrilateral with all four sides of same length but four different interior angles. See, a quadrilateral with all four sides is either rhombus or square. A square has all interior angles equals and that is equals to 90 degrees. Whereas in rhombus, opposite pair you can say are equal. So we can't say all four interior angles would be different. This is wrong. A pentagon with all five sides the same length and five different angles. Yeah, that's correct. You can find a pentagon having all the sides equal but their interior angles are different. So answer is only the pentagon. The length of the three sides of a right angled triangle is 16 centimeters. The sum of the squares of the lengths of the three sides of the triangle is 98 centimeters squared. What is the area in centimeters squared of the triangle? See, this is a right angled triangle. And sum of the lengths of the three sides, that means suppose this is A, B and C. The sum is 16, which means A plus B plus C is 16. Next line, the sum of the squares of the lengths of the three sides of the triangle is 98, which means A squared plus B squared plus C squared is equals to 98. Now till here it seems a little bit different to understand, like how can we proceed? Because it's given as it's a right angle triangle, we have to use Pythagoras theorem. And Pythagoras theorem says the sum of the squares of the legs of a right angle triangle is equals to the longest side, which is hypotenuse. That is A squared plus B squared equals C squared. So here in place of C squared, I can write A squared plus B, or in place of A squared plus B squared, I can write C squared. So let me replace it with C squared. So C squared plus C squared is equals to 98. 2C squared is 98. C squared is 49. On taking root, you will get C is equals to plus minus 7, because when you take root, you will get two different solutions. Here you will get either plus 7 centimeters or negative. For length, negative is not acceptable. So it's going to be 7 centimeters. We got C. If I put it here, I'll get A plus B as 16 minus 7. So A plus B is going to be 9. This will be 9. Now, what we have to calculate? We have to calculate the area of this triangle. That means I need to have the value of A and B. We know area is half times base times height. So half times A times B will give me the area. For that, I should know the value of A and B. We know a squared plus b squared is equals to c squared, and we know a plus b is equals to 9. So this will give us answer. A squared plus b squared is equals to c squared. C is 7. So I can say a squared plus b squared is 49. And a plus b is 9. If I square this, I'll get a squared plus b squared plus 2ab is equals to 81. I just squared both the sides. I have the value of a squared plus b squared, which is 49. So 49 plus 2ab is equals to 81. And when I bring it here, 2ab is equals to 81 minus 49, which is 32. So 2 times ab is 32. AB is 16. If AB is 16, so area will be 16 over 2, that is 8 centimeters squared. Answer is going to be A. I know the space is not good. Obviously, it's very congested. But I have written this one. Let me move on to the next question. Question number 17. A 3 by 2 rectangle is split into 4 congruent right angled triangles as shown in the left hand diagrams. Those 4 triangles are rearranged to form a rhombus as shown in the right hand diagram. What is the ratio of the perimeter of the rectangle to the perimeter of the rhombus? If we'll be able to calculate one side of the rhombus, perimeter is just 4 times the length, and similarly rectangle is also, just add all that up. This is 3 by 2 rectangle. That means obviously perimeter is what? 3 plus 2 plus 3 plus 2, which is 10. So 10 centimeter is the area of, perimeter of this rectangle. It's very easy to calculate. Now coming to rhombus. For rhombus, clearly if it's a rectangle, this is going to be a right angled triangle. We just need this hypotenuse, that is root 3 squared plus 2 squared. But this whole length is 3. So definitely this is going to be half of it. Now, because 4 sides are congruent, 4 triangles are congruent, that means this length and this length would be equal, and which makes this a midpoint. That's why this is 1.5 and this is 1.5. So on applying Pythagoras theorem, this hypotenuse is going to be root 1.5 whole squared plus 2 squared. So 2.25 plus 4, that is root of 6.25, that is 2.5 is the answer. If 2.5 is one length, then perimeter would be 2.4 times 4. This is the length, 2.5 is the length of one side of the rhombus. And rhombus is a figure in which all the sides are equal. So perimeter is sum of all the sides. If all sides are equal, just simply multiply 2.5 with 4. You will get 10 is the answer. So what is the ratio? Perimeter of rectangle is 10. Perimeter of rhombus is 10. Ratio is 1:1. Answer is C. Moving on to the next question. How many squares are exactly 4 greater than a prime number? See, for this one, we just have to write an equation. How many squares are exactly 4 greater than a prime number? That means if I add 4 to a prime number, I should get a square. So how many such are possible? So suppose any square number is n squared. That's the meaning of a square. 4 greater than a prime number. Any prime number represents p plus 4. So when I add 4 to any prime number, I should get a square. So how many such prime numbers are possible in which when I add 4, I will get a square number? So shift 4 here. I'm just writing a generalized way, n squared is equals to p. So prime number is equals to n squared minus 4. If I factorize n squared minus 4, I'll get n plus 2 times n minus 2 is equals to prime number. Now a factor of a prime number is always the number itself n1. That means suppose 3 is a prime number. and I have to find the factors of it. I need to find two numbers. When I multiply them together will give me 3. So two numbers are 3 itself and 1. Even for 17 is a prime number, I need to find two numbers. When I multiply them together will give me 17. The two numbers are always the number itself and 1. That's the meaning of a prime number. So clearly P is a prime number, and it's when you factorize you can see it is n plus 2 and n minus 2, which means clearly one of the factor will be the number itself and another is going to be 1. N plus 2 cannot be 1. Obviously, n is a positive 1. And if you add 2 to it, 1 cannot be possible. But minus 2 will be 1. So, n minus 2 can be equals to 1. From here, I'll get n as 3. So, when I put n 3 here, I'll get n plus 2 equals 5. 3 plus 2 equals 5. So, I get to know n plus 2 is actually 5 and n minus 2 is 1. P equals 5. So only prime number in which I'll add 4 and get a square number is 5. If I solve this, I'll get to know that I'll get only one prime number, such prime number. So, and we can check 5, and when I add 4 to it, I'll get 9. 9 is a square number, which is a square of 3. So only one such number is possible, which is 5. So how many are possible? Just B. Moving on to the next question. What is the positive difference between the numerator and the denominator when the expression shown in written as a single fraction in its simplest form or simplified form? This is the expression. For this, I need to simplify the denominator definitely. And for that, I need to take the LCM to solve the denominator, because whenever I add a fraction or subtract a fraction, we need to make the denominator same. So it's n over n plus 1 minus n plus 2 over n plus 3. This is n plus 1 over 1 actually, right? If you can't see anything in denominator, that means it's a 1. The LCM of n plus 3 and 1 is definitely n plus 3. So I need to make denominator n plus 3. So multiply it with n plus 3. And in numerator also I need to multiply n plus 3. Now I have made the denominator same, which is equals to n plus 3. So now my fraction will become n over n plus 3 times n plus 1 over n plus 3 minus, well, let me write it here somewhere where it's visible, n over n plus 3 times n plus 1 over n plus 3 minus n plus 2 over n plus 3. We need to use a different page, as I don't think so we'll be able to solve it up here. The expression here you can see is n over n plus 1 minus n plus 2 over n plus 3. So as I told you that this is 1 and we have to make denominator n plus 3. So we multiplied it with n plus 3 and multiplied it with n plus 3. So now denominator can be written as n plus 3 times n plus 1 minus n plus 2 over n plus 3. Or let me bring it up there. So it will be n times n plus 3. Now the question is why I brought this denominator up there. Because this is a fact. When I divide a fraction, suppose 1 over 2 divided by 3. It means it's 1 over 2 over 3. Or let me divide 2 with 1 over 3. 2 divided by 1 over 3. It means 2 divided by 1 over 3, which is exactly like this, like the type. So whenever we divide a fraction, we just replace division with multiplication and reciprocal the fraction after it. So 1 over 3 will become 3. And this is the reason I brought it up there. It will become 2 into 3, which is 6. And this is how you solve any fraction. So I'll bring n plus 3 up there. Now let me simplify. So when I expand this, this comes out to be n squared plus 4n plus 3 minus n minus 2. When I expand it, definitely I need to multiply whatever be the number outside the bracket. Now n times n is n squared plus 3n. Let me simplify it. It's n squared plus 3n plus 1. We have simplified it. Now let's go back to the question and see what they are asking. What is the positive difference between numerator and denominator? So numerator and denominator, positive difference. That means we have to subtract bigger and smaller. So smaller from bigger. Bigger is n squared plus 3n plus 1. This is denominator minus the numerator. The question is why I am subtracting denominator first. That means why I am subtracting numerator from denominator, as they haven't specified whom subtract with whom. Obviously they have mentioned the positive difference. So if we want to have a positive answer, always subtract smaller number from bigger number. So this will be n squared 3n plus 1 minus n squared minus 3n, which comes out to be 1. That means 1 is the correct answer. Part E is the correct answer. Okay. I roll 2 standard 6-sided fair dice. At least one of the scores obtained on the dice is 3. What is the probability that both of the scores on the dice are 3? See. When you roll, probability is what? The event, the number of ways by which an event can occur over total possible outcomes. So, when we roll a 6-sided dice, one dice, total possible outcomes will be 6. You can get either 1, 2, 3, 4, 5 or 6. Here, 2 6-sided dice are rolled. That means there will be 36 possible outcomes. 6 to the power of 2. If there will be 3 dice, it will be 6 to the power of 3. 4 dice, 6 to the power of 4. So total possible outcomes depends on the number of dice or number of times you are rolling a dice. So total possible outcome will be 36 in this case. At least one of the scores obtained on the dice is 3. What is the probability that both the scores on the dice are 3? Now see, there is a condition given here. We can't use just 36. The 36 will help us that how many possible outcome will be there. But we have a condition. It says at least one of the dice will have 3. There will be 3 either on this constantly or on this consistently. What is the probability that both of the scores are 3? So what will happen? Suppose if there is 3 on one dice, then the possible outcome will be 3 and 1 on other dice. 2, 3, 4, 5 and 6. These are possible outcomes where there will be 3 on one dice. Now, let me say 3 is on other dice and first dice is changing its number. So, possible outcomes will be 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. These are the total ways by which you will find that 3 will be on one dice at least. But 3, 3 is common, so cancel 1, like one number. So how many possible outcomes are there? It's 11. So that means total possible outcomes are 11. And out of how many events you can see that there is 3 on both the dice? It's only 1. So answer is going to be 1 over 11, which is B. A semicircle of radius 3 units is drawn on one edge of a right angle triangle, and a semicircle of the radius 4 units is drawn on another edge. The semicircle intersect on the hypotenuse of the triangle as shown. What is the shaded area in square units? See, if you see this one, you can clearly understand like it's something is that we have to add the areas of semicircles and subtract a triangle. So when you add, this is area of the semicircle, this red one, and then you add the area of this, again this semicircle over it. What's happening? You're just getting a whole surface. These two have already covered this one. But while doing this process, this intersection is get overlapped, this part. You have added them twice. Obviously, when we were adding the red part, red semicircle, we have included that intersection part. And when we were adding the green part of the semicircle, still the intersection part we are adding. So what we are doing, we are adding this intersection point 2 times. If we are adding it 2 times, and now if I subtract this triangle from it, if I subtract this, what's happening? Let me just redraw it and you can understand. This semicircle has already included this intersection. And when you added it, the area of this semicircle, clearly this intersection gets overlapped and you have added it again. So this is the sum. Now when you subtract the area of this triangle, this one, when you subtracted it, this green part, suppose this green part has been removed. So remaining is this purple and this red. But since we have added that intersection point 2 times, when I subtracted this rectangle, one intersection points would remain there as it is. That's the reason that when you subtract the area of this triangle from the sum of the areas of these two semicircles, you will get this one and this one as well as one intersection part. So it would be, what's given? The radius is 3 units. This is 3 units. So pi r squared plus over 2 because it's a semicircle. The radius is 4. So pi 4 squared. Here it was 3 squared. This is 4 squared. Again over 2. Subtract half times base is what? 4. Height is 3. Base is twice, which is 8. And height is twice, which is 6. So half times 8 times 6. So this will be 9 pi over 2 plus 16 pi over 2 minus, this is minus 24. If you add 9 pi and 16 pi, you'll get 25 pi over 2 minus 24. So your answer is A. The numbers x and y satisfy both equations, this and this. What's the value of x squared minus y squared? See, if you're going to find the value of x and y individually, then square it, it would be very difficult. Obviously, for this exam, we need not to do endless calculation. And the numbers are very much striking. See, if this is 23x here, 23 is y is here, 977x here, 977y. That means if you add it, x and y comes out to be the same. Apart from it, x squared minus y squared can be factorized as x plus y times x minus y. So if I add x and y, subtract x and y, and then put the value, it would be much easier for us to calculate the answer. So for this, I'm just adding these two fractions. (977x) plus 23y. 2977. On adding, it will give me 1000x plus 1000y. And this one will give you 5000. Dividing both the sides by 1000, x plus y is equals to 5. Okay, we got x plus y. Now x minus y. To get x minus y, I'm just subtracting. So 23x plus 977y equals 2023 minus 977x minus 23y minus 2977. So this would be 4 minus 144. Oh, sorry, it's 23, right? So 944. Similarly, if you subtract it, it would be positive, clearly. Then if you subtract it, you will get same minus 944y. Now if you subtract this one, you will get 449 minus. So you can clearly see 944 is common. Divide both the sides by 944. You will get minus x plus y equals negative 1, or subtract both the sides by negative 1. X minus y is 1. So x plus y is 5. X minus y is 1. So 5 times 1 is 5, which is E. So our final answer is E. It is possible to choose in two different ways 6 different integers from 1 to 9 inclusive such that their product is a square. Let the two squares so obtained be p squared and q squared, where p and q are the positive. What is the value of p plus q? See, try to understand what this question is asking you to do. It says that you have to find, first of all, from 1 to 9, you have to select 6 numbers. 6 any random numbers. When you multiply them all together, it will give you a perfect square, a square number. Like 9 is a square number, 16 is a square number. So similarly, when you mix and match and you'll find 6 numbers, when you multiply them all together, it will give you a square number. Now second time, you will again mix and match and find 6 other different numbers, other different from the first one. And if you multiply them together, you'll get the square number as well. So those two numbers, when added together, what will be the answer? So now the thing is, it's not very easy to select the 6 numbers, but if we prime factorize them, it would become much easier for us to understand. For that, I'll multiply 1 to 9 because it will give me an idea which one to take or which one to discard. So 1 times 2 times 3 times 4 times 5 times 6, 7, 8 and 9. These all numbers from 1 to 9 I have written here. Now I need to convert them into prime factors because prime factors will give me an idea that which number is going to be a square and which one I need to discard. See, 1, 2 is a prime number, right, as it is 3. 2, 4 can be written as 2 squared. 5 as it is. 6 can be written as 2 into 3, 7 as it is, 8 2 to the power of 3 and 9 3 to the power of 2. Now just make the bunch of all these prime numbers. 1 as it is, how many 2's are there? 1, 3, 4, say 5, 6, 7, 8, 9. So, sorry, 7, 2 to the power of 7. Now how many 3's are there? 1, 2 and 4. And 1 5 and 1 7. See, why I have written this? Because definitely to find a square number, the prime number or any number should repeat itself 2 times or even number of times. Not necessarily 2 times, but even number of times. 5 and 7 are single. They cannot form a perfect square, obviously, because they have to be repeated themselves for even number of times. So which two numbers we have to discard? 5 and 7. So out of 9 number, I have discarded 2 numbers. 7 are remaining. And I have to select 6 out of these 7. Now it would be much easier for me to select it. See, clearly I told you that number should repeat itself for even number of times. So 3 is repeating itself for even number of time, that is 4. So 3 to the power of 4 I will write as it is. 2 is repeating for odd number of times. So this can be written as 2 to the power of 6 into 2 into 1. Now I get to know this time for the first random selection I am discarding 5, 7 and 2. So from 1 to 9 what I did, I have discarded 2, 7 and 5. So remaining numbers are 1, 3, 4, 6, 8 and 9. When I multiply them together, this is equals to p squared. So on taking root, p will be 3 squared into 2 to the power of 3, which is 8 times 9, 72. So we got our 1p, which is 72. Now let we see other combination. Again, because 5 and 7 cannot be taken in any combination. Next combination will be 1 into 2 to the power of 7 into 3 to the power of 4. Because it's repeating itself for even number of time, there is no possibility of discarding it at all. So 3 to the power will be in. Now 2 to the power of 7, previously we have separated out 2 to the power of 7 as 2 to the power of 6 into 2. Because I was separating even and odd together. Now the next would be 2 to the power of 4 and 2 to the power of 3 can be written. Why I am writing? Because in this manner, because it should be one number itself. So 3 to the power of 4 into 2 to the power of 4, and this can be written as 8 into 1. Which means in this case, in the first case I have discarded 5, 7, 2 from 1 to 9. Now I am discarding 8. So in this case 5, 7 and 8 I am discarding and I am selecting the remaining numbers. So remaining numbers are this. This is equals to q squared. So 1 into 3 to the power of 4 into 2 to the power of 4 equals q squared. On taking root, I'll get q is equals to 2 squared into 3 squared, which is 9 into 4, 36. So this is q. When I add them together, p plus q, that is 72 plus 36 will give me 108. That is D is our answer. If you find it a little bit difficult, just go through this video once again. You'll get it better that why I did that. If you will say that I can take another combination as well, 3 to the power of 2 and discard 3 to the power of 5. See, 3 to the power of 5 is not a number between 0 to 1 to 9. So that's why these are the only two possible ways where I can discard a particular number. So in the first case I discarded 5, 7, 2 and selected the remaining numbers. Whereas in second case I discarded 5, 7, 8 and taken the remaining numbers. Now moving on to the question number 24. A rectangle PQRS has side lengths A and B where A is less than B. This is A and this is B, and clearly A is smaller than B. The rectangle PTUV has side lengths C and D. That's mentioned in this figure. And C is less than D. That's also visible. Also, A is less than D and C is less than B as shown. The sides RS and TU cross at X. Which of these coordinates guarantee that QXV lie in a straight line? See, whether you are doing a straight line thing or a vector, if two lines are parallel or two lines are lying on the same or the points are lying on the same line, definitely their gradients would be same. So if you want to guarantee that QXV, first we locate where these points are. Q, X and V. That means this line. They all line. So what I have to do? I need to find the gradient. So I can find the gradient of VQ and Vx and see whether they are equal. If they are equal, that means they all are lying on the same point. Even you can prove Vx and Xq as well. And if they have the same gradient, you can prove that it's going to be, they are going to lie on the same straight line. So I'm taking this one. So gradient of line VQ is what? Taking these 2 points. Change in Y is D. And change in X is B. So change in Y, that means let me say this point and this point. To move from V to Q, I have to move D downwards. That means negative D. So gradient of VQ will be change in Y. So V is in downward direction, so it's going to be negative D. Over, you have to move B towards right. That means in a positive B direction, you have to move from P to Q. So it would be B. So the gradient of VQ will be negative D over B. Now the next is, let me see Vx. Vx is this. We have to find, if I want to move from V to X, what I have to do? Let me write it down. Gradient of Vx is, I have to move downward till here. This whole is D and this part is A. So this part is going to be definitely D minus A. You can again see this whole is D, this lower part is A, so the upper part is going to be D minus A. So you have to move D minus A negative, right? You are moving in negative side, so D minus A. Over, you are moving from S to X. So whole is B and this is given directly, it is C. S to X is directly C. So you can write it as positive C. Their gradient should be equals to each other. That means minus D over B is equals to minus D minus A over C. So cancel out negative and negative. Remaining is D over B is equals to D minus A over C. Let me see how can we just simplify it. D over B can be written as D over C minus A over C. Now bringing 2 onto the one side, if I bring it here, I'll get, solving it here, D over B plus A over C is equals to D over C. Now divide both the sides by D. So if I divide both the sides by D, I'll get 1 over B plus A over DC is equals to 1 over C. Now if I divide both the sides, but clearly see there is no 1 up there. But let me multiply both the sides by B. So if I multiply both the sides B, I'll get 1 plus AB over DC is equals to B over C. Bring it here. So 1 is equals to B over C minus AB over DC. This is important to remove. You can say A from here now. So what you can do, or once you are done with it, see there are many ways by which you can ultimately reach up here. If you don't want to do that whole stuff, there is another way by which we can do this. See, we know that D over B is equals to D minus A over C, that we have done. So D over B is equals to D minus A over C. You can cross multiply as well. So if you cross multiply, DC is equals to DB minus AB. This would be, I would say, much easier. Now bring it here, DC plus AB is equals to DB. Now from here, you have to look out what they have. In numerator, they have either AC, AB, AC, AD, CB, that combination. What we have DC and AB. So I can divide, ultimately I need 1 here. You can clearly see whatever they are on left hand side, on right hand side it's 1. And on left hand side all are positive. That's the reason I brought negative AB to here, so that I can get 2 positive numbers. We have to work according to the options. So now I need to make this 1. How can I do? If I divide both the sides by DB. Both the sides by DB would be DC over DB plus AB over DB is equals to DB over DB. So as I told you, there are so many ways by which you can simplify it, but according to the options we have to work. So cancelling out D and D, I'll get C over B plus cancelling b, I'll get a over d is equals to 1. This would be our final answer. Let me check it's matching with which one. C over b and a over d, that is C. The matching one is C. The last one is, the diagram shows two unshaded circles which touch each other and also touch a large circle. This is the diagram given. Chord PQ of the large circle is a tangent to the both unshaded circles. The length of the PQ is 6 units. What is the area in square units of the shaded region? Clearly you can see that shaded region is nothing but the area of the whole bigger circle minus area of the two smaller circles. So let I say the largest circle radius of largest be R3, the smaller than that is R2, and the smallest be R1. So pi R3 whole squared minus the sum of pi R1 squared plus pi R2 squared, that we have to calculate. Now let me write it down. Let me see the relation between R1, R2 and R3. This is radius R2. This is radius R1 and whole is radius R3. So center would be here somewhere. R3. This question can be easily understood if I magnify this one. So it's kind of like this diagram. Now we have taken R1 as this, its radius, R2 as its radius. This is R1, this is R2, and this is R3. R3 is the largest one. So this is R3. Now first we have to find the relationship between R1, R2 and R3. Clearly you can see here, if I say what is the diameter of the largest circle, the diameter of the largest circle is this one, no doubt, and this can be written as 2R3. So 2R3, diameter is twice the radius. The diameter of the smaller circle is this one. This can be written as 2R1, and diameter of the second large circle is this, which is 2R2. You can clearly see if I add 2R1 and 2R2, it's equals to 2R3. That's the relationship between them. If I add the diameters of both, it's equals to the diameter of the largest circle. So it will be 2R1 plus 2R2. From here I can write R3 is equals to R1 plus R2. This is the relationship between R3, R1 and R2. So for unshaded portion, we know it's pi R3 squared minus addition of these two, R1 squared plus pi R2 squared. So now we know R3 is equals to R1 plus R2. This can be written as pi R1 plus R2 whole squared minus pi R1 squared plus pi R2 squared. From here I can further simplify it as, when I expand the bracket, it will be pi R1 squared plus pi R2 squared plus pi 2 pi R1 R2 minus pi R1 squared minus pi R2 squared. From here I can cancel it out and remaining would be 2 pi R1 R2. So that means this is going to be the area of the shaded portion. But we don't have the value of R1 and R2. So let me see how can we find that. Now this is the radius. Somewhere here you will find the center of the largest circle. Maybe here. It would be here, the center of the largest circle, which I can say as C3. Now there is a triangle I can draw. Why I'm doing? Because one only known thing that I have is the chord. So I have to utilize this. This triangle. In this, uh, obviously they have named it in the diagram, but let me name it here. OMP. Suppose in this, definitely it's a right angle triangle because this chord is nothing but it's actually a tangent to this circle. Obviously, though it's a chord of the largest circle, but it's also the tangent to the two other circles as well. And we know that, and all C1, C2, C3, they are lying on the same line, straight line. So the angle between the radius and the tangent is always 90 degrees, and that's the reason this is a 90-degree triangle. Now if it's a right triangle, that means I can apply Pythagoras theorem in it. So this is OP squared is equals to MP squared plus OM squared. Now we know what is OM squared. OM squared, one more thing, because it's a bisector also. So I mean it's a chord also. So we know that the perpendicular from the radius to the chord always bisects the chord. That means definitely it's going to bisect it. If this hole is 6, so OM is going to be 3 centimeters. So OM is 3 squared. OP is the radius of the largest circle. Radius of largest circle is equals to R1 plus R2. We just found it. So it can be written as R1 plus R2 whole squared. Now only I need to find MP. MP, that means this part. If you see this part, it's a little difficult to understand, but we know this is the radius. This is the radius. So I can say this part and this part are equal because this is radius and this is the radius. So these two parts are equal. Similarly for this one, this is the radius R2 and this part and this part is equal. We have to find this part. This part, or if I extend it here, it would be like this. We want to calculate this part. If you see this one, this smaller part, this hole, if you can see, this is clearly this hole. Subtract this part. We know this part is what? This part is equals to R2. Okay, let me redraw it to make it more clear. See this the one. Now we know that this is radius R2. This is R2 and this is R1. So if I draw R1 same here, it turns out to be R1 here. This is R1. Now we have to calculate this part. If I draw it here, I'll understand that this part is like this. This R2, if I draw, if R2 is downward, R2 is upward as well. R1 is somewhere here. If you subtract this, you will get this part only, this part. And when I drew the triangle, this part is same. These are equally divided. So from here, though it's a little bit difficult to understand when you look it, but when you draw it yourself, you'll understand that R2 minus R1 whole squared. Now just expand this one. We'll get
r1 squared plus r2 squared plus 2r1 r2 equals r1 squared plus r2 squared minus 2r1 r2 plus 9. So cancel out this one. R1 R2 will cancel. It will go there. 2r1 r2 plus 2r1 r2 equals 9. 4r1 r2 equals 9. R1 R2 equals 9 over 4. We know that shaded portion is 2 pi R1 R2. Now we have the value of R1 and R2. So 2 pi R1 R2 is 9 over 4. So answer is going to be 9 pi over 2. That's your final answer. So that's it for today. If you need one-on-one live online classes, just email us at exacademy@gmail.com, and we have even free worksheets on Exi app for GCSE levels, for IMC, for KS3, KS1. You can access everything there. That's it for today. Thank you and have a great day.